This is a fairly common real-life problem where we can actually find out the molecular formula of an oxide if we know how much iron we start with and then how much oxide we get at the end. Now what you've got to understand is that if you've got an oxide, the oxide is actually the mass, is actually the Fe plus the oxygen. So we know it's some formula FeXOY. And that's what you need to make sure that you interpret oxide to mean. It doesn't mean oxygen, it means some sort of compound with oxygen. So the first thing you should probably do is say to yourself, well, how much oxygen is actually in here? Well, if we start out with 8.00 grams of iron, the iron isn't going to go anywhere. The iron is still going to be part of the compound. But we are going to have oxygen added to it, and that'll give us the 11.44 grams of oxide. So the mass of oxygen in the compound is actually going to be given by the mass of the oxide minus the mass of the Fe, which in this instance is going to be 11.44 grams minus 8.00 grams, and that's going to be 3.44 grams of oxygen in the compound. So that's the thing, just read oxide as being the compound of iron and oxygen. Alright, so first thing we want to do is figure out moles of iron. So we'll start out with 8.00 grams of Fe, and then we'll multiply that, and we'll have grams of Fe on the bottom, moles of Fe on top. 1 mole of Fe, 55.85 grams of Fe, that's the atomic weight. That comes out to be 0.143 moles of iron. Now we take the oxygen, which we just figured up as being 3.44 grams of O. Grams of oxygen on the bottom, moles of oxygen on top. 1 mole of O, 16.00 grams of oxygen. And that's going to be 0.215 moles of O. And as we've done in the past, we'll divide both of these through by the smallest one. So for the iron first, we'll have 0.143 moles divided by 0.143 moles, and that'll equal 1, of course. Now as for the Fe, now we're going to figure out the same thing for the oxygen, 0.215 moles divided by 0.143 moles, and that's going to give us 1.50. And that's for the oxygen. Now we've got something here that really can't be rounded to a whole number because this is too far away, so we've got to figure out what kind of fraction 0.50 will be closest to, and I think we all realize that that's going to be close to a half. So effectively here's what we've got so far. We've got Fe is to oxygen is 1 is to 1 and 1/2. And what we need here is whole numbers, and the way we get there is we can take both of these and multiply them by 2. So what we're going to end up with after we multiply both of these by 2 is 2 is to 3. So that's how we end up getting our empirical formula here as Fe2O3, 2 is to 3.